Okay, hello class, and welcome to this session. So this time we are going to have problems on uniform arithmetic gradient. So uniform arithmetic gradient is a cash flow series that either increases or decreases by a constant amount. Okay, so if we're going to illustrate this into cash flow, so there is an increasing payment. Say this is the cash flow. Say we have this cash flow wherein the initial payment should decrease or decrease linearly. So when we say linearly, uniform ang pag-increase niya or uniform din ang pag-decrease niya. So until the nth period. So this can be expressed by an annuity that is equivalent to the lowest value plus the increasing uniform gradient. So yun yung tinatawag na gradient wherein the increase or decrease will be linear. And that annuity, sabi nga natin, yung pinakamababang value dito. Okay? So madadagdagan na lang ng gradient o yung tinatawag na uniform gradient. So that from this cash flow, itong original, iangat lang natin yan. Okay? Then, taas natin yung period. Then, yan na ang kanyang magiging gradient. So, if you notice, there will be no increase at the first period. No? So, saan magsisimula yung gradient? So, it is occurring right after the first period of this cash flow. So, ang magiging zero ng timeline ng gradient is the first period of the total cash flow. So, ito na ang magiging zero niya. Okay? So, from that, magkakaroon ng G in the second period, 2G sa third period, and 3G for the fourth period until N. So, kung titignan natin, if this is second period, 1G yan, no? So, meaning, N minus 1. Kung ang N mo is 2, N minus 1, or 2 minus 1, that is 1, 1 times G. Parehas dito, ang tapat nito is the third period, pero 2G yun. So, meaning, N is equal to 3, N minus 1, or 3 minus 1, that is 2, times G. So, therefore, until N, kung ano man ang period niya, just subtract 1 from that multiplied by G. So, I have sent you a video prior to this that video derived the formula for the gradient. So, ang nangyari doon is all of this gradient was brought to the present as well as considering the progression or geometric or arithmetic progression formula from algebra, and our formula for gradient was derived. At any rate, we have this cash flow diagram. Itong cash flow na to shall be equivalent to this cash flow. Okay? So, meaning, we will just treat this as annuities, whether we use the present worth or the future worth out of annuity, you know? Present worth out of annuity or the future worth out of annuity, plus the present worth of the gradient. Tapos, similarly, for the future worth, that would be paired to the future worth of the gradient. So, this will be the formula. So, at any rate, alam naman natin yung formula ng present worth of the annuities as well as the future worth of the annuities. So, ang may dadagdag lang na formula dito is the future worth of the gradient, or the future worth, or the present worth of the gradient. So what will be the formula? So I'll suggest that we will just memorize the formula of the future worth, ano? Kasi itong future worth can be brought easily to the present, okay, by multiplying the single payment present worth factor that we have introduced before, okay. So the future worth of gradient is actually denoted by ganun din, finding the future worth given the gradient at I% at n. Now, this expression is equal to a certain formula, but this has to be multiplied by the gradient itself. Okay? So, the gradient itself times this notation, that would be, so lagay natin yung gradient and then salpak yung formula nitong notation na to. And that formula is 1 all over I times parehas dun sa formula ng present worth of annuity, 1 plus I raised to n minus 1 all over I minus n. Okay, so this is the formula of the future worth of the gradient. So the gradient times this notation, ang nidagdag lang from this, no, minus n tayo, and then 1 all over I. Okay, so what about the present worth? So the present worth can be easily derived from this, ano? Kasi we'll just have to bring the future to the present. So the present worth of the gradient is the gradient times finding P given G at I% at N. Okay? So, anong pinagkaiba niyan? So, basically, ang pinagkaiba nito dito sa FG is that we will just multiply this by a certain factor, the single payment present worth factor, to make it on the present. So, ito, copyahin lang natin. We copy that expression and then we multiply it by 1 plus I raised to negative n. Okay? So, you might ask, paano kung yung gradient is decreasing? So, simple lang. We will just have to change the sign, ano? So, if decreasing, we have PA minus PG or FA minus FG. So, magsusubtract lang yung operations. Okay? So, this is the additional formula we need to know when dealing with arithmetic or uniform arithmetic gradient. So, let us try this on example. So, let us have example. Say we have a loan was to be amortized by a group of 4 end of year payments forming an ascending arithmetic progression. The initial payment was to be 5,000 pesos and the difference between the successive payments was to be 400 pesos. But the loan was renegotiated to provide for the payment of equal rather than uniformly varying sums if the interest rate of the loan was 15%. What was the annual payments? So, basically, of course, we need to illustrate first our cash flow diagram. Say this is the cash flow diagram, no? So, the initial payment was to be 5,000 pesos. Okay? And then, the successive payment or the difference between the successive payment was to be 400 pesos. So it is actually increasing by 400. So ilang payment yan? Sabi dito, for end of year. So apat na end of year payment. So that from 0, so this is the first period, meron tayong second period, merong third period, and a fourth period. So, it is increasing linearly by 400 pesos. So, the gradient here is equal to 400 pesos. So, yung payment mo, supposedly sa second year is 5,400. At ito, 5,800. And this one shall be equal to 6,200 pesos. So, ang tanong dito, anong equivalent? Instead na ganito ang babayaran na nag-i-increase, na-renegotiate yun so that it shall amount to an equal payment instead of this one. So, basically, dapat daw, ano bang equivalent na annuity niyan? Okay? Pare-parehas na lang dapat. So, uniform na lang. So, para hindi magulo. So, that was the condition, the problem. Say, this is A, annuities. Okay? And then, so, ang gagawin lang dito is we get a focal period here. So, gamitin ko na lang yung present worth as my focal period. So, all of this will be brought to the present, ano? And then, shall be equated. So, this cash flow is equal to that cash flow. So, let us have the first cash flow. Working on the first cash flow, ano bang meron sa first cash flow? Of course, meron niyang present worth due to A, ano? Present worth due to A plus present worth due to the gradient. Okay? So, ito yon. Ngayon, sa second cash flow, this shall equate to the present worth A prime, ano? Sabihin na natin A prime kasi bagong A yan. Okay? So, what would be the equation of the present worth of our first cash flow? So, gagamitin natin is 5,000, ano? So, the annuity here is equal to 5,000. Okay? Annuity times finding P given A at I% at 4. Okay. And then plus the gradient is equal to 400 pesos times finding P given G at I% at 4 period also. So this is equal to the annuity prime. Say this is annuity prime, no? Annuity prime times finding P given A prime. P given A prime, I% 4. So, we will now apply the notations formula. So, this is 5,000 times 1 minus 1.15 raised to negative 4 all over. I is 0.15. And then for the gradient, we have 400 times 1 all over 0.15. Then we have this expression minus n. N is equal to 4. And then multiply this by 1.15 raised to negative 4. Then equate this to the right hand side. Say the unknown A prime. And we have that expression as well. So those expressions would equate to 2.85, and then let us correct this formula. So the formula for the gradient actually is 1 over I, 1 plus I raised to n minus 1 all over I. So to. So we have 1.15 raised to 4 minus 1 all over 0.15. So all of this shall be equal to 3.786, and then if we're going to manipulate our equation, so we'll come up with an A prime equal to 5,531.43 pesos. So this must be the equivalent payment for this increasing payment. Okay, so that's it for the first problem. So moving on to this second problem, we have here 4 payments, with the corresponding amounts starting from 8,000. So meron tayong decreasing value dito, and obviously the gradient here is a negative 1,000. So putting this into its corresponding cash flow, we have 4 series of payments. We have the first payment to be 8,000. Hence, we have a gradient of 1,000. So nag-decrease yan until the 4th year. Kaya sa 4th year, 5,000 na lang yan. So the question here is, anong corresponding equal amount instead of this decreasing payment annually? Hence, we can write the cash flow as equivalent A prime. So basically, both of these two cash flows has its corresponding present worth. So we will compute the present worth of this as the common focal point here. So the first cash flow may present worth yan, as well as the second cash flow. So the second cash flow is actually the solution. Ito yung corresponding equivalent payment nitong original cash flow. So basically, the present of the original is equal to the present of the proposed equivalent annual payment nitong original. So we can treat the first cash flow as the difference of the present of the annuity of this, So if we construct a line, ito yung line, and we have the corresponding gradient. Because minus yan kasi decreasing yung gradient. So the second cash flow diagram naman is, we can write this as the unknown A prime times finding P given A at I% at 4 periods. So basically, we have an I% equivalent here dapat sa problem. So we forgot to place that. So I'll just have to place on the problem. So assume I is equal to 20%. So all we have to do here is to perform this formula. So for the first term of the left hand side, meron tayong A times finding P given A 20% and 4 periods. So minus the gradient G finding P given G 20% 4. And of course that will be just equated to this right hand side. So substitute na natin mga formula. So yung A natin dito, yung first, lagi yan yung first na cost on the gradient. So 8,000 yan. And then we just substitute the formula 1 minus 1.2 is to negative 4 all over 0.2. So the second term, yung gradient natin is 1,000, then 1 all over I Then we have 1.2 raised to 4 minus 1 all over 0.2, and then 1.2 raised to negative 4. So, equate natin sa unknown a prime, then 1 minus 1.2 raised to negative 4 all over 0.2. So, let us compute the values here. We have that notation as 2.59. Same true with this one. And then, by the way, meron pala tayong minus n dito sa formula. So, we adjust this. We have here minus n, no? So, minus 4. Okay, so we compute. So, we have here 3.298, or we can round that to 3.3. Okay, so by manipulation and solving for a prime, we have 6,725.87. So this is for our gradient problems. So perhaps you can now practice and explore the problems, and thank you for listening.